The biggest star in our galaxy. Hey everyone, welcome to Space Explorer Channel. The Sun is a truly remarkable star. It is the brightest object in the sky and is the largest and most powerful star in our galaxy. Not only does it provide us with warmth and light, but it also plays a crucial role in sustaining life on Earth. It is an essential part of our lives, and understanding its properties can help us to understand how our galaxy works. In this video, we will explore the incredible features of the Sun and why it is the biggest star in our galaxy. Have you ever wondered what the largest star in our galaxy is? Well, it's none other than the Sun. Our Sun is a massive star that is located at the center of our solar system and is responsible for providing life on Earth. It's an amazing star that has been around for billions of years and has been instrumental in the evolution of life on our planet. In this video, we'll explore the Sun's features and understand what makes it the biggest star in our galaxy. Before moving forward, if you are new to our channel, don't forget to like and subscribe our channel for future interesting videos. What is the Sun? The Sun, our closest star, is an awe-inspiring celestial body that has captivated humanity for centuries. But what exactly is the Sun? At its core, the Sun is a giant ball of hot, glowing gas, mostly composed of hydrogen and helium. It is approximately 4.6 billion years old, and its immense mass of about 333,000 times that of Earth creates intense gravitational forces that keep it in a constant state of equilibrium. The Sun's enormous size is difficult to comprehend. It has a diameter of about 1.4 million kilometers, which is more than 100 times that of Earth. If the Sun were hollow, it could hold about 1.3 million Earths. Its mass is about 330,000 times greater than that of our planet, accounting for 99.86% of the total mass in our solar system. This massive size and gravitational pull are what give the Sun its dominance in our galaxy. The significance of the Sun cannot be overstated. Its energy, in the form of sunlight, provides heat and light to our planet. This energy is crucial for life as we know it to exist on Earth. Plants use sunlight in the process of photosynthesis to convert carbon dioxide and water into oxygen and glucose, which in turn supports all other life forms on our planet. Without the Sun's energy, our world would be cold, dark, and lifeless. Compared to other stars in our galaxy, the Sun is classified as a yellow dwarf star. It falls in the middle of the stellar size spectrum, with larger stars known as giants or supergiants and smaller stars called red dwarfs. While it may seem unremarkable when compared to the giants of the universe, the Sun is a perfect size for supporting life on Earth. Its stability and long lifespan of billions of years have allowed complex organisms to evolve and thrive. In the next sections, we will delve deeper into the composition and layers of the Sun, exploring how it sustains life on Earth and the impact of solar flares on our planet. Stay tuned to discover more about the fascinating nature of our closest star, the Sun. In addition to providing heat and light, the Sun also plays a crucial role in shaping our weather patterns and climate. Its energy drives the water cycle, which is responsible for the formation of clouds, rainfall, and winds. Without the Sun's energy, our planet would be a barren desert with no weather or climate to sustain life. Furthermore, the Sun's magnetic field influences space weather and can have a profound impact on Earth. Solar flares and eruptions of energy and particles from the Sun's surface can disrupt communication systems and satellite operations, and even cause power outages on Earth. Understanding the behavior of these solar flares is crucial for predicting and mitigating their effects. The Sun's size and significance. The Sun's size is truly mind-boggling. It's hard to wrap our heads around just how massive this celestial body is. With a diameter of about 1.4 million kilometers, the Sun is more than 100 times larger than Earth. If we were to hollow out the Sun, we could fit a staggering 1.3 million Earths inside it. But it's not just its size that makes the Sun significant. Its enormous mass of about 333,000 times that of Earth creates intense gravitational forces, keeping it in a constant state of equilibrium. This immense gravity is what holds the Sun together, preventing it from collapsing under its own weight. The significance of the Sun goes beyond its size and gravitational pull. The Sun's energy, in the form of sunlight, is vital for life on Earth. It provides the warmth and light that sustains all living organisms. Without the Sun, our planet would be a cold and desolate place, devoid of life. Plants rely on sunlight for photosynthesis, a process in which they convert carbon dioxide and water into oxygen and glucose. This process not only releases oxygen into the atmosphere, which is essential for us to breathe, but it also serves as the basis of the food chain. Animals, including humans, depend on plants for sustenance, making sunlight indirectly crucial for our survival. Furthermore, the Sun's stability and long lifespan of billions of years have allowed complex life forms to evolve and thrive on Earth. Its steady output of energy provides a stable environment for the development of life as we know it. The Sun's steady brightness and predictable behavior make it the perfect star for nurturing life. In addition to its significance for life on Earth, the Sun's size and energy production also affect the entire galaxy. As the largest and most powerful star in our galaxy, the Sun influences the orbits and dynamics of all the other celestial bodies within it. Its immense gravity keeps the planets of our solar system in their respective orbits and prevents them from flying off into space. Understanding the size and significance of the Sun gives us a glimpse into the incredible workings of our galaxy. It reminds us of the interplay between celestial bodies and the impact they have on each other. The Sun, our closest star, continues to amaze and inspire us with its sheer magnitude and the crucial role it plays in sustaining life on Earth. Without the Sun, there would be no seasons, no weather patterns, and no climate. The Sun's energy drives the water cycle, causing evaporation, condensation, and precipitation, which in turn shapes our weather patterns. The Sun's gravitational pull also affects the tides, with its interaction with the Moon creating the ebb and flow of the oceans. But the Sun is not just a source of energy and gravitational forces. It is also a dynamic and active star. Solar flares and coronal mass ejections release huge amounts of energy and particles into space. These solar storms can have significant effects on Earth, disrupting satellite communications, damaging power grids, and even posing risks to astronauts in space. Studying the Sun and understanding its behavior is crucial for predicting and mitigating the impact of solar storms on our technological infrastructure. It also provides valuable insights into the fundamental workings of stars and the universe as a whole. For example, studying the Sun helps us understand the process of nuclear fusion, which powers the star and generates its energy. By observing the Sun's behavior, scientists can gain insights into the mechanisms that drive other stars, leading to a deeper understanding of the universe's formation and evolution. Furthermore, the Sun's solar wind, a stream of charged particles constantly flowing outward, extends far beyond our solar system and interacts with the surrounding interstellar medium. This interaction shapes the local space environment and affects the dynamics of other celestial bodies, including comets and asteroids. How does the Sun compare to other stars? The Sun, our nearest star, is an incredible celestial body that holds a unique place in our galaxy. But how does it compare to other stars? Let's take a closer look. In terms of size, the Sun falls into the category of a yellow dwarf star. It may not be the biggest star in the universe, but it is far from being insignificant. In fact, compared to some of the colossal giants and supergiants out there, the Sun is relatively average in size. These massive stars can be hundreds or even thousands of times larger than our Sun. On the other end of the spectrum, there are red dwarfs, which are smaller and less massive than the Sun. These stars make up the majority of stars in our galaxy, but they are much dimmer and cooler than our Sun. In terms of temperature, the Sun again falls in the middle range. It has a surface temperature of around 5,500 degrees Celsius, 9,932 degrees Fahrenheit, which is much hotter than most stars. However, compared to some of the hottest stars in the universe, the Sun is considered relatively cool. When it comes to lifespan, the Sun is also quite ordinary. It has been shining for about 4.6 billion years and is expected to continue doing so for another 5 billion years or so. This might seem like a long time, but compared to the lifespan of other stars, the Sun is considered to be in its middle age. Some stars burn through their fuel much more quickly and have significantly shorter lifespans, while others can last for billions of years longer. The Sun's unique characteristics, such as its size, temperature, and lifespan, make it an ideal star for sustaining life on Earth. Its stability and predictable behavior have allowed complex organisms to evolve and thrive on our planet. Without the Sun's nurturing warmth and light, life as we know it would not exist. The composition and layers of the Sun. The Sun, our closest star, is not just a massive ball of hot gas. It is a complex and dynamic celestial body with multiple layers and a unique composition that fuels its immense energy. To understand the composition and layers of the Sun, we must delve into the depths of this awe-inspiring star. At its core, the Sun is a nuclear furnace where hydrogen atoms fuse together to form helium through a process called nuclear fusion. This fusion process releases an enormous amount of energy in the form of light and heat. The core of the Sun is incredibly hot, reaching temperatures of up to 15 million degrees Celsius, 27 million degrees Fahrenheit, and exerts intense pressure due to the gravitational forces acting on it. Surrounding the core is the radiative zone, a region where energy is transported through the Sun via radiation. This zone is characterized by a dense plasma of ionized atoms, mainly hydrogen and helium, where photons are continuously absorbed and re-emitted as they make their way toward the surface. This process takes thousands of years as photons slowly bounce their way through the dense plasma. Above the radiative zone lies the convective zone, a layer where energy is transported through the Sun via convection. In this region, hot plasma rises to the surface, cools down, and sinks back towards the core. This convective motion creates a churn-like effect, with plasma moving in large convection cells, similar to the movement of boiling water in a pot. It is this convective motion that gives rise to the Sun's surface features, such as sunspots and solar granules. Finally, we reach the outermost layer of the Sun, the photosphere, which is the visible surface of the Sun. The photosphere has a temperature of around 5,500 degrees Celsius, 9,932 degrees Fahrenheit, and appears as a glowing yellowish disk when observed from Earth. It is in this layer that most of the Sun's light and heat is emitted, providing us with the energy that sustains life on our planet. These various layers of the Sun work together to create its unique characteristics and dynamics. The fusion process in the core fuels the Sun's immense energy, which is then transported through the radiative and convective zones. The photosphere emits most of the Sun's light and heat, while the chromosphere and corona showcase the Sun's dynamic activity. Understanding the composition and layers of the Sun is crucial for studying its behavior, as well as its impact on Earth and the solar system as a whole. By delving into the depths of this awe-inspiring star, scientists continue to unravel the mysteries of our universe and our place within it. The role of the Sun in sustaining life on Earth. The Sun, our nearest star, plays a crucial role in sustaining life on Earth. Its energy, in the form of sunlight, provides warmth and light to our planet, creating the perfect conditions for life to thrive. But the Sun's significance goes beyond just providing light and heat. It is intricately connected to every aspect of life on Earth. Plants, for instance, rely on sunlight for photosynthesis. Through this process, they convert carbon dioxide, and water into oxygen and glucose, releasing oxygen into the atmosphere that we breathe. The sun's energy is the driving force behind this essential process, serving as the foundation of the food chain. Animals, including humans, depend on plants for sustenance, making sunlight indirectly crucial for our survival. Not only does the sun provide the energy necessary for photosynthesis, but it also helps regulate our climate. The sun's warmth evaporates water from oceans, lakes, and rivers, creating water vapor that forms clouds and eventually leads to rainfall. This rainfall, in turn, nourishes the Earth's soil, allowing plants to grow and ecosystems to flourish. Without the sun's energy, our world would be a barren wasteland devoid of life. Furthermore, the sun's stability and long lifespan have allowed complex organisms to evolve and thrive. Its steady output of energy over billions of years has provided a stable environment for the development of life as we know it. The sun's predictable behavior has allowed life on Earth to adapt and thrive, shaping the diversity and complexity of the living organisms that call our planet home. But the sun's impact on Earth is not limited to just providing light and heat. Solar flares, powerful bursts of energy and radiation from the sun's surface, can have significant effects on our planet. These intense eruptions can disrupt radio communications, satellites, and power grids, potentially causing widespread blackouts and communication failures. Understanding and studying the behavior of the sun and its flares is crucial for predicting and mitigating the potential impacts on our technological systems. In addition, the sun also plays a crucial role in our mental and physical well-being. Exposure to sunlight stimulates the production of vitamin D in our bodies, which is essential for bone health and overall immune function. Sunlight also boosts serotonin levels in the brain, improving our mood and mental health. However, it is important to strike a balance and protect ourselves from excessive sun exposure to avoid harmful effects, such as sunburn and skin cancer. The sun truly is the life force of our planet, and understanding its importance and the impact it has on our everyday lives is vital for our continued existence and well-being. Solar flares and their impact on Earth. Solar flares are intense bursts of energy and radiation that originate from the sun's surface. These explosive events can have a significant impact on Earth and our technological systems. When a solar flare occurs, it releases a tremendous amount of energy, causing the sun's magnetic fields to rearrange and release highly charged particles into space. One of the most noticeable effects of solar flares on Earth is the disruption of radio communications. High-energy particles from the flare can interfere with radio waves, causing static, distortion, or complete blackouts in communication systems. This can affect a wide range of communication technologies, including radio broadcasting, satellite communication, and even GPS navigation. In addition to communication disruptions, solar flares can also affect satellites and power grids. The intense radiation emitted during a flare can damage satellite electronics, leading to malfunctions or even permanent failure. This can impact satellite-based services, such as weather forecasting, telecommunication, and navigation systems. Solar flares can also pose a threat to our power grids. When the charged particles from a flare reach Earth, they can induce electric currents in power lines and transformers. These currents can overload the system and cause widespread blackouts or even damage transformers, leading to prolonged power outages. While solar flares can have significant consequences on our technological systems, scientists and engineers are constantly working to mitigate their impact. Space agencies and satellite operators monitor the sun's activity and provide alerts to satellite operators, power grid operators, and other stakeholders when a flare is detected. This allows them to take necessary precautions and make adjustments to minimize the potential damage. Furthermore, researchers study the behavior of solar flares to better understand their causes and predict their occurrence. By studying the sun's magnetic fields and monitoring solar activity, scientists can develop models and forecasting techniques to improve our ability to predict solar flares and their potential impact on Earth. This research is crucial in ensuring the safety and functionality of our technological systems. It allows us to take necessary precautions and implement strategies to minimize the potential damage caused by solar flares. Additionally, the knowledge gained from studying solar flares can also contribute to advancements in space weather forecasting, benefiting not only Earth, but also future space missions and explorations. As our reliance on technology continues to grow, understanding and preparing for the impact of solar flares is essential for maintaining our communication networks, satellite services, and power grids. While solar flares can be disruptive, our ongoing efforts in research and forecasting are helping us navigate these challenges and build a more resilient future. With improved monitoring and early warning systems, we can now better prepare for the impact of solar flares on Earth. This includes implementing protective measures for critical infrastructure, such as power grids and satellite systems. Additionally, advancements in technology allow us to develop more robust and resilient communication networks that are less susceptible to the effects of solar flares. In the future, it is crucial to continue investing in research and innovation in order to further improve our understanding of solar flares and their potential consequences. This includes studying the sun's behavior and magnetic fields in more detail, as well as developing more accurate forecasting models. By doing so, we can not only enhance our ability to predict and mitigate the impact of solar flares, but also advance our knowledge of space weather and its implications for both Earth and space exploration. Studying the sun and its behavior. Studying the sun and its behavior has been a fascinating and ongoing endeavor for scientists and researchers. With advances in technology and our understanding of the universe, we have been able to delve deeper into the mysteries of our closest star. The study of the sun allows us to not only gain insights into its inner workings, but also to make predictions about its behavior and potential impact on Earth. One of the primary methods of studying the sun is through solar telescopes. These specialized telescopes are equipped with filters that allow scientists to observe specific wavelengths of light emitted by the sun. By analyzing the different layers and features of the sun's atmosphere, such as sunspots, solar flares, and prominences, researchers can gain a better understanding of the processes and phenomena occurring on the sun's surface. Another valuable tool in studying the sun is space-based observatories. These observatories, such as the Solar Dynamics Observatory, SDO, and the Solar and Heliospheric Observatory, SOHO, provide detailed images and data about the sun's activity. They can observe the sun in various wavelengths, allowing scientists to study the different layers and dynamics of the sun's atmosphere. In addition to observations, scientists also use computer simulations and models to study the sun. These simulations incorporate the laws of physics and known data about the sun to recreate its behavior and predict future events. By running these simulations, scientists can simulate solar flares, magnetic field changes, and other phenomena, helping them better understand the sun's behavior and its potential impact on Earth. Studying the sun is not only about understanding its physical properties, but also about understanding its impact on Earth and the solar system. By monitoring solar activity, scientists can predict and prepare for solar flares and other solar events that could have significant consequences on Earth's technology and infrastructure. This knowledge allows us to take precautions and develop strategies to mitigate the potential damage caused by these events. The study of the sun is an ongoing and ever-evolving field of research. With each new discovery, scientists gain a deeper understanding of the sun's behavior and its importance for sustaining life on Earth. By studying the sun, we can unlock the secrets of our universe and continue to explore the wonders of the cosmos. Furthermore, studying the sun helps us better understand other stars and their behavior, as many stars exhibit similar processes and phenomena. The knowledge gained from studying the sun can be applied to distant stars and expand our understanding of the universe on a much larger scale. Moreover, studying the sun also contributes to our understanding of climate change and its impact on our planet. Solar activity, such as variations in solar radiation, can influence Earth's climate patterns. By studying the sun's behavior, scientists can improve climate models and predictions, leading to better strategies for mitigating the effects of climate change. If you enjoy this video, don't forget to like and subscribe to our channel for interesting future videos. Thanks for watching.